Okay, let's look at how do we apply data science in business. So when we begin a data science journey, right, remember that data scientists mainly deal with businesses, yeah, because that's what we are good at. We want businesses to achieve better results. And when we deal with businesses, right, it usually revolves around two things. It's either help them to increase revenue or to reduce costs. And let's look at how we can use data science to answer different questions in business to achieve that two goals. But before that, let me ask you a question, right? Um, just just think straight, yeah. Do you think that using data science to increase revenue is easy, or using it to reduce cost is easy? Yeah, cost saving is a lot easier. The main reason why cost saving is easy because, especially if you're working with larger corporations, right? There is a lot of leakage. There's a lot of wastage here and there. You can always find somewhere that people are wasting money or not doing things efficiently. So to increase the efficiency or optimize the efficiency by 1% is it's not that hard, right? But to increase revenue, increase the sales by 1%, that is a lot harder than people would expect. Yeah, because that's beyond our control. Okay, good ones. So the types of questions data science can help to answer primarily fall into these three categories. Now, if you think of it, right, these are the types of business questions that your bosses always ask you and always wanted to know as well. For example, the first one is this A or B? Okay. Number two, how much or how many? And number three, how things are organized. Okay, basically to understand what does the data tells you. Yeah. Let's look at the first one. Is this A or B? Now in data science, right, this is a problem that we call a classification problem. Now in classification problem, we use classification methods to answer questions with binary answers usually, right? For example, will this employee leave our company next? Yes or no? Will these subscribers or will these users unsubscribe our service next month? So Maxis and DG is asking this question all the time. Who is going to leave us? Who is going to jump from us to Cellcom, for example? Okay, you see this in marketing as well, right? We come up with uh, different version of our advertisement, and then the boss always asks which one is more effective. You think version A and B, because they need to know how much money they put, how much money budget they need to allocate for each of the advertisement. And you see this like digital marketers also use classification methods, right, to do this sort of A/B testing as well, right? When it comes to classification tasks, right, we can also extend this to more than two options, meaning that is this a A, B, C, D option? This is what we call multi-class labeling as well. It's very useful when we have multiple or several different possible answers, and it helps us to determine the most likely one. Like Netflix use that a lot. They need to categorize the movies like thriller, romance, adventures, and you might be thinking like, isn't this the type of movie has been predefined when the movie is released, right? Yes and no. The director might think that this is a thriller or this is a romance movie, but in the viewer's eyes, they might think that this is actually a comedy, for example, or sometimes they can have multiple classifications. So this is when uh, algorithms or models like this help us a lot. The second type of questions that we answer, business people always want to know, is how much or how many. Now, how much or how many actually relates to forecasting. You want to forecast a value, the answers. So, for example, uh, we use regressions method to help us to forecast values like temperatures, the sales, the price of particular commodities. And for example, what will be the temperature tonight, and what will be the sales of our order be. We always use regressions method to help us to identify the cause and effect relationships between variables. So the relationship between driving speed and accidents by a driver can be easily modeled using regressions method, and this will help us to identify significant relationships and indicate the strengths of impact for the variables. And next one is how are things organized. Now, if you look at the methods that I have shown you, right, the two questions that we talk about, classification and also regressions, right? Classification, basically, we are doing a prediction. We want to predict what is the outcome. And forecasting or regressions is basically for us to forecast a future value. The common thing between these two questions is that they both require input data to have no numerical value. So you basically need to have a training set to input those value in order to train the model. But sometimes in practice, we don't have the luxury to get all the training data, right? So even like Google, Facebook, they are always collecting your data. But with so many points, right, you cannot be sure that all this data is labeled. So what we need to do is we're going to use a method called clustering and unsupervised methods to answer the questions how is this organized. So supervised method require the class or labels to be provided during training, but for clustering, you don't have to, because clustering method they group items together based on their similarities of features. Now, for example, if you are running a movie rentals companies like Netflix, right? These data points can be the users who watch a particular movie, and if you are a hardware manufacturer, it can also be the data points of your printer fail. For example, if you look at the circles that are drawn at the bottom right, we can classify them into printers who fail in 3 months time, who fail in 6 months times, printer who fails in 18 months time. And then from there, we look at the common things. So is it because of the power supply? Is it because of the toner? Is it because of the drum that we use? And this is very useful. So from there, we can use it for different types of analysis. Usually we use it for profiling, recommendation, and also study the characteristics for recommendation as well. Now, if you look at the groupings at the bottom, right, people who fall under the same grouping, who fall under the same clusters, usually demonstrate similar behavior. So people within the clusters will you can cross recommend them same type of movies. Okay. So now that you understand the type of questions that we can ask and we can use data science to answer, let's look at the tools and algorithms that we usually use. I think I've mentioned it many times already. In data science, it's all about Python, and these are the. I wouldn't say that these are the only languages that we use in data science, but this probably 80% of data scientists know at least one of the language and they use here. Now, R is a programming language that is designed by academicians, therefore mainly used by statisticians and uh, researchers, because many of the syntax and notations are based on statistics. So people will find that if you don't have any programming background, you find it very difficult to learn R at the beginning. So the learning curve at the thing is quite steep. Okay, so there's a problem with R. And a lot of my students are before they come to our classes also say that you just need to wrap your head around some of the concepts because of the notation is different. And you also find that R, right, when it used to process a large amount of data, is slightly slower. Yeah, but the good thing about R is that because it has been used by academics for so many years, right? So it has a huge statistical analysis library. Now, on the other hand, Python is a language that is designed by computer scientists and used mainly by programmers, web developers, and scientists. Now, you know that astronomical scientists, right? They use Python libraries to render this picture. You know this picture? If you do not know, that's okay. This is the picture of the black hole simulation. So, Python also has a very concise and simpler and beginner friendly language, which makes it easier for beginners to pick up. And not only Python is popular with data science and scientific is often used by other engineers in startup development and production. And last but not least, because is so popular, therefore it has a strong community support. Now, what does it mean? It means that you can easily find answers from various problem places like Stack Overflow, and you can easily Google them to get results. So, well, question is, which one should you use? Now, in fact, short answer, it doesn't really matter, right? It really depends on your background. Someone coming from computer science background find that Python is relatively easier. And then, uh, if you're an academic or statistician who happen to have learned R during your uni or research time, then you may stick with R now and only picks up Python language later on. When you need some of the unique features, for example, integrate with web applications. So that's one of the main reason, like, yeah, people who write codes in Python and use Python for web development and also uh, other type of scripting. Now, if you're a total beginner, right, then I would suggest you actually to pick up Python first, because not just Python is beginner friendly language, it's also very popular language that we can use it to automate tasks. Now, what does it mean is that you can use it to find jobs easier if you learn Python. And most important thing, right, is both programming languages, they are free and open source. You can download and set up both on your machine, give it a try and see which one you find easier. Now, after all, programming language is a tool, so you just need to pick up the one that does the job best for you. Now, if you see the survey here, right, there are other programming languages as well. Like I mentioned, Java, all this for the portions and script as well. But yeah, the portion is very low. So only if, because the work environment objects that you're handling are using those language, you can choose those language. Other than that, no specific reason. Okay, either one is fine. And the that you need that we was earlier is that must you know programming language in order to learn data science, right? A short answer, no. If you don't really want to learn programming to start with, there are many other alternatives available for you to perform data science and data science tasks and learn data science. But one thing I really want you to know is that a lot of people has been using this as an excuse. Alamak, I learn data science. If I need to learn data science, I need to learn programming. Yeah, I'm not from programming background. Programming is so hard. All excuses. Don't let these excuses or this little voice get into your head. Okay, don't need to know programming in order to learn data science. Okay, you can use graphical tools, like for example this one. Weka is a tool that comes with machine learning algorithms for different data mining tasks, such as data preparations, classifications, clustering, association rule mining, and visualization. Now, it's an open software developed by University of Waikato in New Zealand, and this tool is popular within the scientific research community and support different types of file formats. So feel free to download it and give it a try. Okay. And second tool is RapidMiner. RapidMiner is a workflow-based data science tools that provides components and operators like the one that you see on the left to handle the entire data science life cycle, from data preparations to machine learning, and also to build predictive models. More of uh, Miner is open source, but you have to pay for the studio, okay, which is free for the first 10,000 record, but the is quite steep and quite expensive after this. So if you have a smaller data set, right, it's a nice tool to try out. And lastly, your favorite everyday tool, Microsoft Excel. Now, Microsoft Excel is a very powerful tool for data scientists, even data to perform preliminary exploratory data analysis. The reason is very simple, because the limitation in terms of their columns and number of rows. So, but if you want to have some sort of exploratory data analysis, you just want to check something out, analyze your data, explore data a little bit. Is actually a very handy tool, because everybody has Microsoft Excel in their computers, right? Even if you don't, you still have Open Office, or what do you call it, Google Sheet as your alternative. So spreadsheet program is everywhere. And look at the example here, right? We are using Microsoft Excel to build a model to predict breast cancer using a structured data set. But the problem is that while graphical user interface tools are very good, and it makes your life easy because you can just drag and drop and click here and there. GUI graphical programs by nature are not really efficient when it comes to the large data set. The processing time might cause the programs to be non-responsive. Like when you're installing a software, the progress bar start at 99%. You wouldn't really know what happens until the entire operation is finished. It can be done, but it requires further strategy to partition the data and trial and errors. Also, because it's a graphical tools and we save the models in proprietary formats, it makes it very difficult to share results and works in a collaborative environment in a large project. So you can't use any version control tools like Git or GitHub to track your changes. And last but not least, you should be well aware that graphical tools usually do not come with any scripting capabilities, and it makes the task not reproducible. To explain it in the layman terms, right? I can build an Excel spreadsheet yeah, with 20, 30,000 rows with some formulas. But when I pass this Excel spreadsheet to Ruben, say for example, right? Ruben wouldn't understand what I've done, right? Ruben wouldn't understand what are my thought process. So if he want to fix something, he cannot fix from the top. He fix from the end. He can from the very beginning. So Excel is good at formula calculating data across different cells and worksheets. Yes, but when it comes to things like batch loading data, let's say you have 1 million data points and you want to load 10,000 at a point of time, right? It's impossible. Yeah, Excel can't do that effectively for you. And also a lot of things like cleansing data is very difficult as well. There are also other powerful software, SAS, Teradata, that I'm not going to discuss here because those are very expensive, specialized professional software. And the reason why they are expensive and they're professional software is because they require licensing fees and they do give enterprise level of support. So it's not so suitable for you as an individual data scientist who are just begin to enter the field. Or actually at the flip side, right? Let's talk about it. If you learn data science this way, you learn Python, you learn R, you learn all the techniques and algorithms, and you go to a company that are using uh, SAS or Teradata, right? And that's no problem at all. Yeah, you can do that. You can easily pick them up. So next, we're going to talk about the types of algorithms that you need to know in data science. Now, the word algorithm itself might scare some people, like, yeah, but you are here in my webinar. I explain to you. Long story short, algorithm is the way for us to get to build our machine learning models. Now, when we talk about machine learning models, if you still remember what we've discussed earlier, machine learning models can be broadly classified into two types: supervised learning and unsupervised learning. Learning is for us to teach a machine to understand our physical world, and eventually the machine can act by itself without human instructions. And let's look at the two different types of machine learning here. The main difference between supervised and unsupervised learning is that, if you still remember, supervised learning requires us to have knowledge, a prior knowledge of what is the output values. We need to know the historical data. Yeah, meaning we have to provide data that has already been labeled as the data sets. And what supervised learning actually does is to map a set of input variables to output variable y. So, given, tell me what is the y. And theoretically, the more the data, the better model it will be, and able to perform more accurately on unknown example. Supervised learnings are usually used to predict labels using classification. So if you see things like spam mail, predicting customer churn, predicting the sales, etc., right? And that is predict. Yeah, and we can also use it to predict the future values, such as the sales volume, the property price, using regression. So the two tasks that we do in supervised learning is prediction and also forecasting. And some of the common supervised learning methods are decision linear regressions, and also logistic regressions. These are the common popular ones. This is the example of decision. A decision tree is a tree. As you can see, it looks like a tree. Yeah, it's a tree graph to model possible consequences and including the conditions and outcomes. It looks like a flow chart which each nodes, nodes means the boxes here, okay, represent a test on a feature. Now, if you look at the example from this example, right, this is Titanic data set. Tested on we tested on the passenger class, we tested on the fare that each passenger pays us as well. So each branch actually represents the outcome of the test, and each leaf nodes represents a class label, which is the decisions um, determined by the model after computing all the attribute. So we can learn the classification rules that decides the outcome. So if this is the first time you have encountered algorithms and models, right, this is actually what a lot of people, a lot of data scientists likes to use, because they can easily show this and explain it to their bosses, stakeholders, easier for lay to understand. And in mathematics, regressions is a method to estimate the relationships among variables. It's a method to model and analyze variables. Now, for example, we can use a linear model to predict future values and forecast the impacts, performance rating, risk assessment. For example, in this chart, right, we're trying to predict the effect of spending money in TV advertisement and how it actually impacts our sales. Another common regression technique here is logistic regression, mainly used in classification like using handwriting, detect spam mail, or to predict whether an employee will resign or not in HR use case. Now, if you look at the chart, right, logistic regression is giving us a score, and that score usually is a probability score between 0 to 1. And in this example is that the output is the probability of passing an exam given the number of hours somebody have put into study. So the more hours that you put into study, the higher the chance of the possibility that you'll pass the exam. But you'll see that usually the top and the bottom, they will not touch the 1 and 0, because no matter how well you prepare, there's still a possibility that you fail the exam. And no matter how not prepared you are, right, some people, they can still pass the exam. Okay, and let's look at the unsupervised learning methods as well. Unsupervised learning methods are useful when we don't have the ground truth, meaning that you don't have any labels for the data. We don't have access to those training label data. So we learn the structure of the data without using any labels. So it's a total opposite of supervised learning. And we often use unsupervised data to discover groupings to learn underlying rules and similarity associations from our data set. And the common unsupervised learning algorithms are clustering and also dimension reduction. Clustering is a very methods used in unsupervised method in data science. We use clustering to find different groups within elements data. So what it does is to make sure that we find the structure so that elements of the same cluster are more similar, and the most similar one are grouped together, and externally the difference between one cluster and the other cluster has to be significant as well. So for example, in this chart, right, we use k-mean clustering, a very popular clustering method, to group the data points into three different groups. And based on their similarity and how similar the data points are within their own respective clusters. So long story short, to summarize, right, machine learning is actually for us to learn how to make decisions with the training data given to it. It gets progressively better when given more training data.